Hey, Vlad here, devinsidey.com. Welcome to another video. I made two videos in the past about the models of computation with a big focus on the substitution and the environment models. In this video, I would like to recap only one aspect of those models, right after the intro. Okay, so this video is about two things. One, it's about the Scala's class hierarchy, and two, it's about the notion of equality in programming. Equality in the sense of comparing two things to each other in order to find out if they're the same or not. In the substitution model of computation, no one even talks about equality because there are no problems with it. Every symbol that you use is considered an identity for the thing that is on the right-hand side of the equation for that object. So for example, over here, the symbol x is merely an identity or an alias for the value on the right-hand side. In fact, the whole notion of substitution relies on a very strict notion of equality, very strict laws for equality, because otherwise you wouldn't be able to substitute something without being able to guarantee that the thing that you're substituting equals to the thing that you're substituting it with. Now, in the environment model of computation, the notion of equality becomes astronomically more challenging because remember, the variable, the symbol that you're using cannot be only considered merely an alias for the value on the right-hand side. It is always a pair for some code and the pointer to the environment where the code was created. The environment is mutable. It can change during the execution time of the program. The state is trapped inside of the environment, and the whole necessity for the entire model of computation, called the environment model of computation, was the presence of assignment in our language, which breaks the substitution model. A common example for issues with equality is a two-dimensional point like this one. It's just a pair of x and y coordinates, and the question is, what if the point changes during the execution time of the program? Will it still be equal to the point before? And intuitively, in real life, you would say, well, of course not, and you might be right. But remember that we're not talking about the real life, we're talking about the model of the real life, right? And in the environment model of computation, we have a one-to-one sort of ratios, right? So we have an object in the real life, and we depict it with a computational object in our model, right? So the question is the computational object going to be the same, right? And again, intuitively, you might still think that of course it should change. Well, how about a different example? What about a bank account? Let's say you have a bank account, and if the balance changes, should it still be the same bank account? Right? And yet another issue is introduced by subtype polymorphism. For example, should a colored point be equal to a regular point without any color with the same coordinates, right? Should it be the same point or should it be considered a different point? Now, objects in the substitution model are usually called values, and the objects in the environment model are usually called references. Values are things like point or a colored point. They're merely data structures. They show data, but they hide behavior. So this basically means in Scala that they would rather have vals than defs, even though in Scala the distinction between them is very thin due to the uniform access principle. But one is behavior, defs, and the other one is just data, vals. And references are almost diametrically opposed to data structures. These are objects like, for example, the bank account, which hide data, right? They hide the var with the balance, but they expose behavior, defs like withdraw or deposit. Now, one of the motivations for Scala was to make Java better, and only once that failed, it changed to make a better Java. But this is a topic for another video. However, this time we actually have to start with Java. Now, Java has two sort of kinds of types. It has primitive types, which are things like Boolean or int, and it has the object types. And you can call them however you want. You can call them value types and reference types. You can call them primitive types or class types. You can call them data structures or objects, right? Because in the end, it all comes down to do they expose data or do they expose behavior? By the way, I'm not sure if you noticed, but dualities like this are very common in our field, a sense of conspiracy. Now, usually when primitive types in Java are discussed, the whole conversation is about efficiency. The primitive types are optimized, so to say, because additional effort is required to construct reference types. But in our case, we don't care about this entire discussion. Unfortunately, our problems are much bigger. And by the way, right before I explained what data structures are and what objects are, and I said that something like a point is a data structure, but on this slide, the point is on the right. And we're going to get to that in a few minutes. Or, Now, so in Java, you compare primitive types with the double equals symbol, but the problem is that we can't create our own primitive types. We can only use the ones that are built in. So if we wanted to create a data structure like point, for example, we would have to basically abuse classes for that. And every class in Scala extends another class called object, and the object class, it defines the method called equals. So basically you compare primitive types with the double equals symbol, and you compare reference types with the call to the equals method. And then whenever you create your classes, which automatically extend object, you can define the equality yourself, right? So you can just override the equals method, which accepts any other object, which we're going to talk about in the next slide or a few slides after that. It just returns a Boolean, right? And in our case, because it's a data structure, we would compare the structure, right? So we would compare this x coordinate with that x coordinate, and this y coordinate with that y coordinate. And then we have to make sure that what we're dealing with here are reference types. So if we take them and we compare them with the equal sign, with a double equals symbol for primitive types, the answer is going to be false, even though we defined equality to be structural, right? So we have to remember to use the equals method. Now, since the point is a data structure, it makes sense to compare its structure in the equals method. But if we had an object instead of a data structure, like for example a bank account, which syntactically would look the same, right? It would still be a class bank account. It wouldn't really make sense to compare the balance, right? It wouldn't really make sense to compare the structure. However, it would make sense to compare something like a bank account number. So in the equals method of a bank account, we would compare this account number. And it turns out that defining the equality method, defining the equals method yourself is actually quite challenging, but we're not going to talk about this today. We're going to have a dedicated video about this at some point in the future. For now, just trust me that it's kind of hard. In fact, to this day, it remains an area of active research. Now, what we'll talk about today is how unfortunate this decision was to impose sort of equality on every class, right? Because some classes, actually most classes, are going to be objects and not data structures. Well, actually, I'm not sure if it's going to be most of them, but let's say half. So half of the objects are going to be actually, half of the classes are going to be objects, right? So maybe it doesn't make sense to compare them to each other at all, compare them with each other at all, right? But still, because we have to use the class keyword, we have to extend from object, and therefore equality is sort of defined for us. And I wish that I could tell you that Scala came along and fixed this whole equality issue for us, but unfortunately it didn't. And sometimes I actually feel like it made it a little bit worse, but only sometimes. The first issue is kind of obvious. The difference between the double equals symbol and the equals method is very error prone. Like even experienced developers constantly make errors like this. They just forget to switch them, unless they're only writing Java. But usually when you're deemed as an experienced developer, by that time you know at least like 10 different languages, and you probably program in your free time in a different language. So so then when you go back to work, you still kind of you mix it up sometimes, right? And beginners, they fall into this trap all the time. And by the way, Scala fixes actually that part. Number two, in my humble opinion, I believe that the difference between those two methods is just an excuse for the inability of creating our own primitive types. Some other languages like C, C++, or C#, they have a keyword struct instead of class, which allows you to create objects that behave like data structures. But back in the day, it was cool to be able to create a language which is purely object-oriented. And back then, it was assumed that in order to be pure, everything has to be an object, except for the primitive types, but that was just an optimization, as already mentioned. The issue number three, as already mentioned, literally every object can be compared with any other object, right? Because every object is an instance of a class, and every class extends object. And I believe this should not be like this. I believe it should be in the programmer's hands to explicitly state that, okay, what I'm creating here is a data structure, and therefore I want to be explicitly, I want to explicitly state that I should be able to compare it for equality, right? So it shouldn't compile automatically, right? If I'm trying to equal it to something else. So just to sort of iterate, what are the reasons? Why is the equals method actually define an object? Well, there are two reasons that I can think of, and the first one is that we have to abuse the class keyword to define our data structures, right? Because there's just no other way. And equality for data structures is their bread and butter, right? It's very important for data structures. And by the way, at least in theory, they could have called it, the double equals symbol, but Java does not allow, Java only allows alphanumeric symbols, right, alphanumeric methods, right? So this would not be a legal identifier in Java. And second, I don't know, maybe they thought that it's kind of good to leave a hint that, you know, this is a data structure that you have and this is a reference type that you have. And the reason number two, there's simply no alternative. Java doesn't have no multiple inheritance, it doesn't have virtual modifiers, it doesn't have linearization. For instance, in Scala, we could have had a trait that defines the equals method. In fact, it could define this one over here, right? Because Scala allows for more symbol than just alphanumeric ones, right? And then when we're building a data structure like a point, we could decide, okay, you know, this is going to be a data structure, so I'm going to mix this trait in, and then it will have this equals method. That would be actually kind of cool. But sort of unfortunately, Scala chose to remain compatible with Java, right? So every object can be compared literally with any other object, right? Because remember, equals accepts an instance of any object as its parameter, right? So you can compare anything to absolutely anything, right? Like, for example, in this case, we're comparing an integer to a string. And in Scala, as we will see in a few slides, at least there's no distinction between the double equals symbol and the equals method. This one and this one, so they will always yield the same result. Now, in my opinion, this whole notion of imposing equality on every object, on every class, is the biggest mistake in the world of programming. Now, we say that null is a billion-dollar mistake, and we haven't talked about null on this channel yet. We're actually going to start talking about this in this first video. Anyway, in this video, anyway, we're saying that null is a billion-dollar mistake, but I believe that this is a gazillion-dollar mistake. There are two things that I want to mention at this point. They're basically like a sidebar. There's a commercially available compiler plugin for Scala called SuperSafe, and it's done by a company called Artima and by a guy called Bill Venners, who's very known in the Scala community. He was one of the first ones. He actually co-authored the original programming in Scala book together with the creator of Scala, Martin Odersky, and Lex Spoon. Anyway, so this compiler plugin, it makes sure that certain cases like this, that they don't compile. But as I said, it is commercially available. It also has a community edition, but I played with it for like 5 minutes, and I don't believe that it covers, the community edition covers those cases. I'm going to make an entire video about the plugin in the future, and I'm going to leave a link down in the description. And the second part of the sidebar is that Dotty, also known as Scala 3, is going to come out in the next few years, probably even by the end of 2019, and those issues with equality are actually being addressed there. And I believe they go by name Multiversal Equality, and I will leave the link down in the description. All right, let's finally start looking at Scala's hierarchy. So whereas in Java, there's basically no hierarchy, there's just object and everything extends object, in Scala, it's a bit more complicated. So at the top, we have a class called Any, and this is the class that defines, you know, the equals method. And right under it, we have AnyVal and AnyRef. AnyRef overrides the equals method, and for a very long time, until Scala 2.10, it was considered an alias for Java's object. And the thing is that back in the day, you know, the idea was that Scala should not be only able to run under the JVM, it should also be run on the .NET environment, for example, which didn't happen. But at least these days, Scala transpiles to JavaScript, and also it compiles all the way down to native code, which is kind of cool, but not the topic of this video. On the left side, Scala has the class called AnyVal, and until Scala 2.10, it was not possible to extend it. It only had the built-in types, which are exactly the same types as the primitive types in Java, plus the type unit, which has only a single value. And by the way, in Java, there's this concept of void, which is just a keyword, right? It's not a type. Now, as I already mentioned before Scala 2.10, AnyRef was considered to be an alias for Java's object. But now, since Scala 2.10, since you're actually able to extend AnyVal yourself, I guess any becomes an alias for an object, but I'm not sure about that. What I do know is that if you have a method like equals, which has a parameter, as a parameter, it has an instance. It wants an instance of object. You can give it an instance of any when you override it, and everything is still going to work the same, right? So I believe that any should be considered an alias for object, right? Not AnyRef. Now it sounds like from Scala 2.10 we can define our own AnyVals, basically, where we can extend AnyVal. Now it sounds like this is a mechanism for creating our own data structures, but hold your horses. The reason for AnyVal was to achieve the same level of optimization that built-in primitive types have, right? So the goal was not to provide mechanics for creating data structures. In fact, AnyVals, like every extension of AnyVals, has to abide with quite a few rules, and one of them is that it can have the class that extends AnyVal is only allowed to have one instance variable. In fact, to be more precise, it must have exactly one instance variable. So if you want to declare something like a point, which has two instance variables, you know, the x parameter, the x coordinate and the y coordinate, you can't extend AnyVal. And we're going to talk about AnyVal in some dedicated video in some time in the future. As of right now, I'm just going to leave a link down in the description with all the rules. Now, we'll come back to the hierarchy in a second, but let's take a look at any. This is what is inside of any. So we see this equals method, right? And as you can see, as a parameter, it doesn't accept object, it accepts any, which makes it, I guess, an alias to object, right? It also has a final def double equals, right? And also final def bang equals, right? Which is the opposite of equals. And by the way, this is the template pattern that we stumbled upon in the video about inheritance, right? So the idea is that the users, you know, when you extend any, or you know, any ref, you create, you know, you override equals, right? And then the equals symbol just merely delegates to the equals method, right? It also has methods like hash code, which is very much related to equals, but again, you know, as I already mentioned, it's kind of involved to declare a perfectly valid equals method. And one of the things that you have to make sure is that you, every time you override the equals method, you also override the hash code method, which again, I'm going to talk about this in some other video. It also has other methods like as instance of that we already used, and also is instance of to check if it is an instance of something. It has the toString, which we already also stumbled upon, and it actually has get class, which we also stumbled upon in the previous video about traits. We stumble upon it in the example about the cars. Now, it sounds like an improvement over Java, you know, this whole template pattern that you know, you can't mix up the double equals symbol and the equals method, but still nothing forces us to implement the equals method. In fact, if you go to any ref, which is right here, equals is actually, you know, you don't see it really here, but it's overridden from any to compare the references, right? So if we declare a class point with x and y, if we compare them, it doesn't matter if we compare them with the double equals symbol or if we compare them with the equals method, the result is always going to be false, because the default implementation of equals is it's the comparison of the references, right? So if it's exactly the same reference, so if you say val a equals new point with the coordinates 1 and 2, and then you just compare a to a, then it's the same reference, right? Or if you say val b equals a, right? So b is now just another pointer, just another pointer to just another reference to the same object, right? Then it will yield true. But this is not what we want. We want structural equality, and nothing will warn us if we forget to implement the equals method. Now let's go back to the hierarchy and see what's under any ref. Well, basically every else is under any ref. So every Java class is essentially under any ref, because remember, any ref or any, you know, they're just an alias for Java object. And all the Scala classes are also extending any ref, and they also mix in a marker trait called Scala object. And if you've never heard the term marker trait, a marker trait is just a trait which does not have any members, right? So it doesn't have any defs, it doesn't have any vals. So all it's doing is just basically changing the type a little bit, and something, in this case in the Scala compiler, checks for that type, right? So something in there does, okay, is instance of Scala object, and then it treats them somehow a bit differently. Now, what's interesting is that the story doesn't end there. Scala actually has two very interesting types at the bottom of the hierarchy, and they're there to handle some corner cases in Scala's object-oriented type system, which we're going to discuss right now. At the very bottom of the hierarchy, there is a type called nothing, which extends everything, which totally makes sense, I know. The goal of it is to handle exceptions, and I know that we haven't talked about exceptions much in this channel yet, so here's a crash course. Every method that you call, it can terminate, right? It can finish its execution in a normal way by yielding some result, or in an abnormal way by throwing a so-called exception. And in some other languages, like for example in Python, they use a different terminology. They raise exceptions instead of throwing exceptions, but this is just a different naming convention, and that's it. Exceptions are regular classes, but instances of them, in contrast to being just being able to pass them around, you can also throw them. There is a special keyword in the language that allows you to throw them, and every time you throw an exception, the type of this expression is nothing. And it's also possible for the caller to handle the exception, but this is a topic for another video. In an expression like this one, we have val result equals 1 divided by 0. Which type does the result have, right? It should be int, but the division by 0 is actually going to throw an exception. And if, as I just mentioned, the fact that an exception is thrown produces an expression with a type nothing. And because nothing extends everything, also int, nothing extends int, then the result of this whole expression is going to be int. So the simple subtype polymorphism will kick in, and the Scala will reconstruct the type to int. And by the way, nothing, the type nothing actually doesn't have any values, right? So we have a unit which has only one value. We have nothing that doesn't contain any values at all. And in a second, we're also going to be talking about null, which, similar to unit, contains only one value, null, but this time lowercase null. So null is the other type at the bottom of the Scala's hierarchy, and in contrast to nothing, which extends everything, null only extends the reference types, and its goal is to represent an environment that hasn't been initialized yet. And we haven't talked about this on my whole channel, because in 100% of the cases, null can be avoided, and there's a chance that in all of my videos that are going to come in the next years, hopefully my channel is going to survive that long, there are changes that will almost never see null again. Here's an example for null. We have a simple bank account which has some sort of account number, and it has only one behavior, only one def called show account number. So when we call it, all what's happening is that we're just printing it out, right? So if you want to play around with nulls, which you shouldn't, by the way, you need vars, right? Because if you're creating an environment that is not initialized yet, Scala will not allow you to do this if this is a val, right? Because if this is a val, then there's no way for you to initialize it later. So you need a var, which is already bad, and now you have a null over here, right? So later, you basically mutate the account variable, right, where you actually instantiate the environment, right? And only then you can call show account number. Now, see, the thing is that nothing will prevent you from calling this method before you actually initialize the environment, right? So over here, this one will actually throw a Java long null pointer exception, right? And this is the biggest problem was this thing that the type system has no way to tell you, hey, this variable has not been initialized yet until it's too late. It can't tell you this at compile time. So you can obviously check for null, right? But you can only check that at runtime, and it's super easy to forget. In fact, everybody forgets this all the time. Now, I'm usually trying to keep my emotions out of my videos, but this is a very retarded programming style, and as already mentioned, even the inventor of null considers null to be the $1 billion mistake. And you can Google that if you want to know more about this. Just please don't do this, or if you do this, don't tell anyone that you learned this on my channel. All right, so what are we going to do about all these issues with equality? Well, as I already mentioned, in the future, I'm going to create a video which is dedicated just to this topic alone, right? How do you implement the equals method and the corresponding hashcode method? But until then, you just follow this recipe. See, the thing is that in my over 10 years of experience, never did I have to actually implement the equals method myself, unless it was for educational purposes, of course. The thing is that integrated development environments, which is a topic that we haven't talked about this in this channel yet, or short IDEs, they can actually generate the whole equals method for you based on the structure of your class. And in Scala, you don't even have to do that, right? In Scala, you don't even need to use an IDE. Just follow this recipe. Step 1, decide up front if what you're building is a class that is going to represent a data structure or an object. Step 2, if it's an object, then stay away from equals. For instance, if you have something like a bank account, then instead of overriding equals and comparing basically the structure, so instead of comparing the account numbers with each other in the equals method, just compare them outside, right? So if you have a bank account A and you have a bank account B, if you want to compare them to each other, then do this: A dot account number equals B dot account number, and that's it. If you implement the equals method yourself, you're opening yourself to a world of errors. For example, have you thought about what is going to happen if you actually if somebody goes ahead and extends your bank account? Have you thought about that? If you don't implement equals, then you don't even have to think about that. The steps 3 and 4 are self-explanatory, I hope. Don't use vars in your data structures, and also don't use other reference types in your data structures, right? So just having vals is not always enough. Step 5, use case classes. So prepend your classes with a keyword case, and what it will do is it will tell the compiler to generate a structural implementation for the equals method and for the hashcode method. And in addition to that, it will generate a factory method and a few other cool things that we're going to talk about in some other video. Step 6. Always use final with your case classes. A final basically turns subtype polymorphism and inheritance off, because object-oriented concepts like these have nothing to do with data structures. In fact, in the next video, we're going to talk about algebraic data types, and there we will actually use inheritance or subtype polymorphism, and this is an exception. So case classes in Scala are basically there to represent data structures, and you might wonder, why aren't they always final then? And the answer is, it's complicated. Some other time. I'm sorry. Step 7 is just a cherry on the top. If possible, extend AnyVal. So if your data structure happens to just have one instance variable, extend AnyVal. As soon as it compiles, you can't go wrong. This is the final implementation of the point. This is how it should look like. You have a final case class point, and you have a final case class colored point. And colored point uses another point, right? And point is a data structure, right? This one, it's not some other reference type. It contains only vals. It's completely immutable, so it's fine. And a color, right? So the colored point, for example, does not extend point or things like this, right? Data structures should have nothing to do with object-oriented concepts, right? Always ask yourself this: what do other languages do that are not object-oriented? They have to deal with data structures somehow, right? So don't touch object-oriented concepts. Okay, so we have println 0.12 equals 0.12. It will be correct because the case will tell the compiler to generate the perfectly valid structural implementation for the equals method and for the double equals symbol. Now over here, it will return false, right? And unfortunately, it will compile, but at least it will give you a warning. And in the last case, if you want to compare a point to a colored point with the same coordinates, right, then just convert the colored point into a point, right? Just basically rip out the actual point out of the colored point, and then if they have the same coordinates, then it will return true. And this is how the bank account looks like, right? So even though all we need to do is to compare account numbers with each other, we're not overriding equals, right? To avoid situations like this where a PayPal account extends a bank account, and then you're going to try to compare a bank account to a PayPal account, and then you're going to run into issues with equals. Just use the structural equality yourself, right? So write it out manually. You have a bank account, say dot account number, use the regular equals. Well, in Scala you can always use the regular equals, and compare it to the PayPal account, and it will return true. All right, this has been the part 1 of the video about objects versus data structures, and in this video we learned about the Scala's hierarchy and the issues related to equality. And in the next video we're going to talk about when to use objects and when to use data structures. All right, it's been Vlad, devinside.com. Subscribe if you want to improve the developer inside you, and most importantly, take care.